Hello, and welcome to this session of a presentation. Today, I'm going to present on the OHDSI environment on a standalone Linux server that has been done for our Inspire project. The OHDSI environment consists of many tools, and I'm going to discuss some of the tools that we have installed for our purpose of producing the OMOP common data model and pushing it to Atlas for data visualization and characterization. So the first thing that we installed was a white rabbit and rabbit in a hat. So white rabbit is used to scan input data sets and produce a very basic rudimentary data profiling, which is provided as an input to the rabbit in a hat. The rabbit in a hat is used to design the ETL. And remember, it's just only to design the ETL and not to produce any ETL code. So you need to use some ETL software or ETL tools to implement the ETL that has been designed using rabbit in a hat. The other tool that we have used is called Usagi, which is an offline tool and very helpful in mapping the vocabularies from the source to the OMOP CDM or the OMOP Common Data Model vocabularies. It's helpful because it gives suggestions. It gives suggestions for mappings based on the textual similarity of the code descriptions that we have in the source. Like, for example, male, and then it'll search for all the males in the OMOP vocabulary. It's a very useful tool, and it can be used offline. And interestingly, it produces a very nice output, a dictionary of all the mappings that you have implemented in the project. So this really helped us in producing that mapping and dictionary for us. You can also use Athena. Athena is a web-based repository, and it helps us to search and load standardized vocabularies. So if we do not want an offline tool to be used, we can just go to Athena and search for the vocabularies. The other one is called Achilles, which is a software tool that provides for characterization and visualization of a database conforming to the common data model. So we have used the R tools provided by Achilles to produce the analysis results. And then those analysis results were visualized on the Atlas web interface. So Atlas is, again, a free, publicly available web-based tool that facilitates design and execution of analysis on standardized patient-level observation data in the common data model. So now I'll just quickly demonstrate the different tools. These different tools that I have used on our installation, our local installation on a Linux server, just to simulate a OHDSI environment and to produce the required data sets. And it's always useful to have a local instance with all the OHDSI tools, because we have more freedom in installing and upgrading the tools. And we produce, or we prepare the data that's going to be the final outputs. So I have prepared my data and produced the results and then put it on Atlas. So now I'll start demonstrating the tools one by one, but I'll not go into the technical specifications or the process of running the tools. I'll just show you the tools that we have used and how to open those tools to use. There are more videos coming up where we'll be going into the details of each and every tool, and we'll explain how these tools are used. So first, I'm going to start with White Rabbit and see how White Rabbit is accessed. So after we have downloaded, it's just a zip file that we download, and after we have extracted, we get these files. We get files for the Windows environment with an extension of .bat. It's a batch file. And for the Linux and Linux environment, we get the scripts, the shell scripts with a .sh extension. So these are the 4 files that we get for 2 for the white rabbit and 2 for rabbit in a hat. So I'll just tell you how to open this or how to access these software tools. So we just go to that folder and I just give /white rabbit and it opens the white rabbit tool where we set up the working folder. This is the folder from where we will pick up the source data if needed, if it's a text file, and we are going to store the output into this folder. So we can set a folder here. By default, it's a simple text file that it takes. It's a delimited text file, a comma separated file, or a tab separated file. Or we can use different databases. So we can also have these databases as our input. So once the input has been given, we scan and we generate a scan report, which is going to be stored in the working folder. So that's going to be the scan report. That's going to be our profile of the data. And that's what we're going to give input to the rabbit in a hat. I just close it now, and I'm going to show you a rabbit in a hat. So for rabbit in a hat, again, I just give a ./rabbit in a hat. And this is, again, a graphical user interface tool, which is used to do the variable mappings and the vocabulary mappings. Again, it's in another video that we're going to show you the details of how to do those mappings. But here I'm just showing how to open the tool and how the interface looks like in this tool. So first we give we open the scan report. So once we open the scan report, the input tables come over here, and then we do the mapping. Now, once we have done the ETL design, we need to implement the design, and we have used a Pentaho data integration tool for implementing the ETL. So this is the tool. We have used the community edition of this tool. It's a very versatile drag and drop tool. So we just drag the components and drop it in our workspace to configure those components to work. So here, like I have created a repository called IDSR, and here you can see there are many files for different versions. So I have version 1, 2, and 3. So I have many versions. So I have used a folder for creating my source data, which is a synthetic data for IDSR that has been created. It's a very generic synthetic data. So some transformations have been done to create this. And then we have the CDM. So in the CDM, we have blocked it into different folders for populating the demographic related data, the disease condition, specimen, and other things. So let me just try to show you how it's all chained and we are working. So we have a master file, which is chaining all of these transformations. And it's just one click and go, and data is migrated from source to the target OMOP CDM version 6.0. And then also it produces the version 5.4. And after we have produced the OMOP CDM version 5.4, we need to use the Achilles R tools to produce the results, which can be viewed on Atlas. So this is the R tool. So it's a simple R packages that we have. So there's a R package called Achilles, which we need to install on our environment, connect to the database, set our environment, that is the source data, my CDM data, the version of the CDM data, the schema in which it is going to store the result analysis, and the vocabularies from where it's going to pick up the vocabularies for producing these results. And then simply it's the Achilles function, which has been used from the Achilles package. And that's going to produce the Achilles tables. And then we can also index it for speed of accessing those data from Atlas. So this is about the Achilles tool that we have used to produce our results data set. So all the databases that we have produced, all the data sets that we have produced are being put in a PostgreSQL database. So the example which I'm just trying to demonstrate here, to show you here, we have a lot of database schemas under a database called OHDSI. So here we're talking about a schema called the CDM IDSR 5.4 version 3, and the ETL has produced these tables, all these tables which are the standard OMOP version 5.4 tables. So these tables have been populated, and after that, we have the results. So here I have the results IDSR 3, version 3, and here we have the tables that were produced. So these are the first 4 tables that was created using the Achilles tools. And then we have a lot of other tables which gets created when we run the scripts provided by OHDSI. And then we have the vocabulary database. The vocabulary has all the vocabularies, the concepts, the concept ancestors, and other things that are available. So, as it is available in the Athena, so it has been downloaded and pushed into this database schema called vocab. And we have created only one vocab database so that we don't have to repeat this bulky schema. It's very bulky, it's very heavy, so we don't have to repeat that. So all the other analysis is actually using the same vocab schema. And then we have this schema for the web API. So this is basically a metadata schema, which the Atlas uses and the Achilles uses to fetch their data. So we keep on adding data sets using these schema, and the analysis results are also the characterization results are also stored in the tables in this web API schema. So this is basically a metadata for the Atlas. So this is all about the database that we have produced. And lastly, we move to the visualization, and that's through the Atlas. So in Atlas, we have different data sources. So if you can see, we can select a data source from here. And let me choose a data set, the data source, which I've produced, the latest one. This is again a synthetic data. And this is a very generic synthetic data that's being created. So you can see the different reports. So it's going to give the total number of persons in this data set with the basic distribution by gender, the age at first observation, and other things. And we have the different reports, the data density, the person, it gives the details about the person, the visits that has been done. So here the patients have visited a health center, and then their case report form was filled in the health center. So the place of visit is the health center. So you've taken this as a health center here. The condition occurrence of different type of conditions, we're just concentrating on COVID-19 and leaving apart the other ones. But with COVID-19, we have a lot of other symptoms. Like with the COVID-19, we have the associated symptoms like a loss of taste, sore throat, difficulty in breathing, loss of sense of smell, nausea or vomiting, headache, or generalized body ache, nasal congestion, diarrhea, fatigue, fever with chills. So these are the associated symptoms with COVID that has been uploaded. The condition era. Then we have the procedures. So here the procedure is the vaccine that we're talking about. So this is the COVID-19 vaccine that we have in a database. So drug exposure is the COVID-19 vaccine. The different type of vaccines were there from different companies. The measurement is the test that has been done. So it's measurement of COVID based on saliva and based on blood. Saliva is for the PCR and blood for the antigen test. These are the observations that we have recorded, some observation of the specimen that were collected, the notification of disease. So COVID-19 was a notifiable disease. So whether it has been reported to the district administration, and any travel history of the patients. And lastly, if there was any death, so we captured the death. So this is about the reports that we have in Atlas. And then we can, based using the concept sets, we can create our own cohort definitions, and we can also do a characterization. So leave this for another day. There will be a demonstration on how to do the characterization and what has been extracted from the synthetic data. So that will be another demonstration another day. But for now, it's thanks and goodbye.